this is the next Higgs video. It's Higgs Decay, HERA, Detector, Beam, Obsidian, Lead, UA5, CERN, Dark Matter formula. So this one has a formula in it. September 29, 2012 is when I started doing the research, and today's November 15th. The keyword search is for the HERA 1, HERA 6, Higgs mass boson particle videos. This is part 2 of the previous video. Be tagging HERA Higgs Boson Particle Decay Signal Bottom Quarks CERN. That's the title of that video. Summary of particle detectors. A particle detector. Here's a picture of it. Okay, and a summary of particle detectors. In experimental and applied particle physics, nuclear physics, and nuclear engineering, a particle detector, also known as an irradiation detector, is a device used to detect, track, and/or identify high-energy particles, such as those produced by nuclear decay, cosmic radiation, or reactions in a particle accelerator. Modern detectors are also used as calorimeters to measure the energy of the detected radiation. They may also be used to measure other attributes, such as momentum, spin, charge, etc. of the particles. Description. Detectors designed for modern accelerators are huge, both in size and in cost. Yeah, they are super big. The term counter is often used instead of detector when the detector counts the particles, but does not resolve its energy or ionization. Particle detectors can also track ionizing radiation, high-energy photons, or even visible light. If their main purpose is radiation measurement, they are called radiation detectors. But as photons are also massless particles, the term particle detector is still correct. My thoughts. September 19th. I'm reading this data and something strikes a familiar chord with me. The idea is that a beam travels through Obsidian, a sphere. I Google it and look what comes up. Formula math equations for line 18, A3Z, 5AG. That's a video that came up from my YouTube. So, and then CERN and Janet Conrad find a particle mass with that splits. Again, that's on my website as well. And I got a proton-antiproton collision recorded using a spark chamber at the UA5 experiment at CERN. Keyword was spark chamber. And then a PDF file comes up, the UA5 streamer chamber experiment at the SPSP Collider in Bonn, Brussels, Cambridge, CERN, Stockholm. Collaboration presented by J.G. Rushbrook. The abstract is a multi-particle detector based on 2 large 6 long streamer chambers triggered by surrounding scintillation. Photoscopes and viewed by cameras via image intensifiers is being assembled at CERN and tested at the ISR. Its purpose is to perform our first rapid visual survey of the new energy region afforded by the SPSP Collider. Charged tracks can be observed down to 3/4 degrees, and hence over most of the pseudo-rapidity range. I don't know what that means. Your guess is as good as mine. Covered by high multiplicity events, lead glass plates are being placed within each chamber to convert gammas produced within the same N range. The apparatus is hence particularly appropriate for the detection with high efficiency of the so-called Centauro events thought to be characterized by very large multiplicities. There's another equation there. And by very few company neutral particles. That was from 1980. It's iopscience.iop.org. September. My thoughts and formula ideas. Okay, so we're going to take this experiment and change the lead glass plates with obsidian ones, mixed in with the formulas provided, to find sparkles or neutrinos, dark matter, and the Higgs boson particle with larger mass, staying power so you can study it. Instead of converting gammas, you convert a liquid argon gas beam with neutrinos in it at high temperatures, plus colliding the particles to generate massive amounts of energy. CML, ATLAS, CERN, Tevatron, W7, Stellarator. Particle accelerators combine your powerful components from each experiment collider to see what you can simulate in your hypothesis theories that you've worked on in the past, present, and future. Okay, thank you for watching. I'm going to go into the next Higgs video.